I guess over here, just 1 second. Just 1 second. This is W1911. Yes. Okay, let's start. Acha, coming back to the ester question, right? What you were saying was, where's the ester question? This one. So the double bond O goes to this side, and an OH group gets added to it. Is that clear?
Yeah, okay.
So the double bond O goes over here, and the OH from water gets added, and on the other side, an H gets added. As anyways, coming back to the paper.
Yeah, right. Thank you.
I said let's start very quickly. We have got starting with the first question: which compounds produce 3 different organic products when they're hydrolyzed? So that's the same question. Esters are going to break down. So ester breaks down. So would it produce 3 organic products, the first one, or not?
2, right?
It's going to be
produce 3.
1, 2, and I mean this side, this carbon atom. What happens to it? Double bond O, right? So it turns into carboxylic acid. What happens to the other side? So what happens to this one? That turns into an alcohol, right? This one, double bond O side turns into carboxylic acid, and this last one turns into an alcohol. So you'll have so you have 3 different products. So one is correct. What about the second one? The esters will break. This one will break. The ester over here will break. So how many products do you get in this case?
3.
3 as well.
Now you're going to get 2 products, because this side will turn into OH. The middle part will turn into the double bond O will turn into double bond O and OH, and you'll have carbon chain down, up, double bond O, and that side would also turn into carboxylic acid. And then you have the last part. The last part will be OH, right? So the 2 ends are the same thing. The right side and the left side, they're exactly the same. It's 1 carbon atom and alcohol. This one is 1 carbon atom and alcohol. Is that clear?
Yes, sir.
So in this case, so this is not right. Although it's breaking up into 3 things, but 2 of them are exactly the same thing. And this one will also break down into 2 things, because the ester will break and this ester will break. But
sir,
when, yes.
सर वो सेकंड के अंदर तो 3 प्रोडक्ट्स बन रहे हैं ना?
नहीं, लेकिन वो end वाला, the 2 at the ends, they're exactly the same.
Okay, sir. Okay, sir. Thank you.
That's why you're getting 2 products. This one you're going to get 2 products as well, because the middle part will break. So this thing over here in the middle, the bond will break. Ester bond breaks, right? And once that breaks, this side would turn into carboxylic acid. This side would turn into alcohol, right? So in that case, you don't get 2 different. It's still connected together, right? This ester will break over here, so that thing will break, and once we're going to break that. So the ester will break, and this side turns into alcohol, this side turns into carboxylic acid. So basically you're getting 2 products because the molecule did not split completely. Is that clear? So this is also wrong.
Sir, why would it
Yes,
not
sir.
split?
Because the ester is splitting over here, but the molecule is still connected from the other side. Is that clear? I mean, it's still one piece, right? Like it did break at this point, but the whole molecule did not split into 2 parts. ठीक है, is this clear?
Yes, sir. Sir, general question.
Yes.
These type of questions, they've been removed from syllabus, right?
No,
Or-
esters are there.
No, not esters, like from 1, 2, and 3, which ones are correct? Yeah,
I said,
like that type of
see,
question.
that is removed. It's going to be A, B, C, and D, right?
No, ma'am,
but-
general question, sir.
ठीक है. I mean, that is obviously removed. You only get A, B, C, D questions. Maybe you can. I mean, you did get questions like these in O levels as well. I mean, they might give you a key and they will tell you which one is A, B, C, D. So that is possible. But you won't get. Previously, you get 10 questions for sure on this, like 1, 2, 3 pattern. But now it's not there.
Sir,
Okay, sir, thank you.
sir, ये pattern खत्म हो गया?
हाँ, मतलब 1, 2, 3 pattern is over now. You'll only have A, B, C, D. ठीक है. So remember
Okay.
that you'll only have A, B, C, D. 1, 2, 3 is no longer there. You might get questions on this like these. I mean, you also got questions like these in O levels as well. So when they give you that question, they'll give you the marking key as well. Like what does A mean and what does B mean? Okay. But the pattern is over. Like previously, you had 30 ABCD questions and 10 1, 2, 3 questions. But now all 40 of them will most likely be ABCD questions. So this one, hydrogen cyanide reacts with propanone in the presence of potassium cyanide catalyst. So the intermediate behaves as a base. I guess all three are correct. He's talking about nucleophilic addition. So one by one.
So इसका आंसर A होगा.
Okay, that's going to be A. All three look to be correct. So I'll explain. Let me open this. So nucleophilic addition, you've got, this is nucleophilic addition. You've got an aldehyde or ketone. Cn-1, what does it behave as? It's an addition reaction. Obviously, it's nucleophilic addition. So that is one of the statements correct. Cyanidine acts as a catalyst. That is also correct. The Cn-1, it initially comes from the catalyst. The last
Sir?
one is the intermediate behaves as a base. It is behaving as a base because it is accepting an H+1. So that is also true. Hanji.
So ये behave as a base को explain करते हैं?
What is a base to it? Accepts H+1 ions, right?
Yes, sir.
So if it accepts H+1, so what is the mechanism doing? In the intermediate, you get this negative ion, and that negative ion accepts an H+1 ion. Is that clear?
Okay, वो H का start करो.
So which compounds on heating with an excess of concentrated sulfuric acid produces only one of the molecules? So what happens when you heat an alcohol with concentrated sulfuric acid? It's this part, it's dehydration. The alcohol loses the OH and with concentrated sulfuric acid, it turns back into an alkene. So you got alcohols and he's saying will produce only one product with the molecular formula C7H10. So this carbon atom, the OH is lost. When the OH is lost, you got two options for the double bond. The double bond could either be over here or it could be either on this side. Since this is a symmetric molecule, it doesn't matter. Right? Is that clear? That it doesn't really matter whether the double bond is on this side or the double bond is on this side. And this one as well, the OH will be lost. And there's only one option for the double bond, and that's this one. So you're getting this molecule. And it's a symmetric molecule, so it doesn't really matter whether the double bond is here or here. So you only get one type of product. It's only going to produce one type of product. Is that clear?
Yes, sir.
As the next one, again, the OH would be lost, and the H would be lost from the neighboring carbon atom. You get a double bond at this point, and that's the only point. Over here, the OH would be lost, and the H would always be lost from the top one. Because a double bond cannot form over here. This carbon already is making too many bonds. So this one will also produce just one organic product. Only one of them. Because the double bond cannot be at this position because this carbon cannot be making more than 4 bonds. Is this clear as well?
Yes, sir.
So with this one will give you, this one is the wrong one. the OH will be lost. You'll get a double bond on this carbon atom. That's the only position that's possible. The OH would be lost. Now you have got two options. The double bond could be on this side or the double bond could be on this side. So you've got two options and that would result in two different molecules. So you won't get only one product, you'll get two different products. ठीक है, ये भी clear?
Yes, sir.
सर
हाँ.
सो ये थर्ड वाला मार्कोवनिकॉव्स रूल को तो नहीं रेफर कर रहा?
This is not Markovnikov's rule. Markovnikov's rule is for addition reactions. This is an alcohol turning into an alkene. So Markovnikov's rule is when an alkene turns into an alcohol. Okay? So this is elimination. So it's all about OH. This has no rule. The OH is lost. The double bond will have two options. It could either be on the left side or it could be either on the right side. Okay, is that clear?
Yes, sir.
The structure of Trichloroethylene acid is this thing. Which statement about the properties of one molecule of this acid are correct? So it contains 2 pi bonds. Is that correct?
1 pi bond.
Sir, 1 pi bond.
That
You
is
can
correct.
make one with oxygen.
Yes, exactly. Because
Oh,
they're showing just 1 pi bond, but there's a pi bond over here as well. There's a C double bond O and OH. So wherever you have a double bond, so it's got a double bond over here. So it's got 2 pi bonds. It contains 4 lone pairs of electrons. So is that correct? 4 lone pairs. Let me draw the whole molecule. Does carbon have lone pairs? Or do H atoms have lone? Who has lone pairs?
Carbon.
Oxygen.
Oxygen. Carbon never has lone pairs. Carbon has 4 electrons. All 4 of them, normally all 4 of them get used up. So it's only oxygen that has lone pairs. So this is C double bond O and OH. Hydrogen doesn't have lone pairs. It doesn't have electrons. It just has 1 electron. So how many lone pairs does one oxygen have?
2.
Two, exactly. So there are 4 spare electrons. So 2 over here and 2 on this one. So you do have 4 lone pairs. It has all atoms in the same plane. So is that correct now? Again, you're getting a lot of planar questions.
No.
Which atoms are not in the same plane?
Can you just repeat the oxygen part?
ठीक है. These hydrogens are not in the same plane because that is tetrahedral. So if I draw the hydrogens in the 3-dimensional arrangement, it's going to look like 1 bond coming out of the page, 1 going into the page. So the CST,
voice and screen and oxygen and everything, I guess.
which one?
Voice in your screen. They're not in.
Sorry. Can everyone hear me?
Yes, sir.
Yeah, sure, we can hear you. I think
Yes, sir.
So ठीक है. नहीं वो internet is going. You need to sit closer to the computer. Achha, so this one. Achha, but let's talk about this question. Are the carbons in the same plane in this question? Are all the carbons in the same plane?
No.
They are actually in the same plane. Like if you look at this carbon atom, right? And you look at this carbon atom, they're going to be trigonal planar, right? So let's talk about carbon number 1 and carbon number 2. So these 2 carbon atoms would be fan shaped. They would be trigonal planar, right? The first one. This is carbon number 1. It has an H and it has a C attached to it, right? And this other one is your second carbon atom. That's also trigonal planar. And that one has C's attached on both sides. It's got a C and it's got another C. The top one, this one, the third one is also trigonal planar. So that's it's got a double bond O and it's also going to be fan shaped, right? So these carbon atoms are all in the same plane. What comes after these carbon atoms, they're not in the same plane. Like the carbon at the end, that's tetrahedral. So any atoms or bonds, they would be coming out of the page or going into the page, right? That will be tetrahedral. But these carbon atoms, fan shaped. This carbon atom, again, fan shaped. This other carbon atom, that's also fan shaped. So the carbon atoms are all lying in the same plane. Is that clear?
Sir?
Yes.
So लेकिन जो CH3 वाला ये तो same plane में नहीं होगा I guess.
See, the C is in the same plane as the C, but after that it's tetrahedral, so the hydrogens are not in the same plane. Is that clear?
Okay. Yes.
Even one of the hydrogens is in the same plane. These two hydrogens are not in the same plane.
So yeah, I don't get it. So will 3 be correct or no? It won't be, right?
It won't be because they're talking about all atoms.
Yeah.
I was just talking about explaining how the carbon atoms are in the same plane.
Oh,
The hydrogens are not in the same plane.
right.
As the next one, nitrogen gas is unreactive, whereas oxygen gas and chlorine gas are reactive. Which statement helps to explain this difference? Are held together. That's obviously true. Triple bond between is not polar. The bonds. So is the second statement true?
No.
The first part of the second statement is true. The second part is obviously not true. See, the second part is definitely not true because the Cl2 bond is non-polar, right? The dipoles will cancel out. So remember, there are two reasons why the nitrogen molecules are unreactive. One of them is that it's got a strong triple bond. The other one is it's also non-polar. It's got no charges, so it's not going to attract anything. So this first part of the statement, second statement is definitely true. But the other one is actually technically wrong. The atoms in N2 have second one statement that makes second statement wrong. They all have full outer shell electrons, so that is also wrong. N2, O2, and Cl2, they all have complete outer shells. So which statement are correct? Chloride ions are oxidized when concentrated sulfuric acid. Is that true? Chloride ions are they oxidized? Are they easily oxidized?
So वो तो H2SO4 act करता है as
Yes,
acid.
because they are good oxidizing agents.
The chloride ions. Okay, remember this difference that just let me open this.
No, they're not oxidized.
So वो सब as acid.
Remember the halide ions are reducing agents because they're supposed to lose electrons. So whenever you talk about the halide ions, you talk about them as reducing agents. The element is the oxidizing agent. So Cl-1 does not like to lose electrons. It's a small ion, it's a negative ion. It does not like to lose electrons. It attracts its electrons very, very strongly. So no redox reaction happens. Only displacement happens in this case. So in this case, the first one, they're not oxidized. So first is wrong. A disproportionation reaction happens with chlorine with NaOH. That part is true. That whenever you have chlorine with NaOH, you get NaCl, NaClO, and H2O. If it's cold, if it's hot, it's going to be NaClO3. An acidic solution is formed when chlorine is added to water. That is also true because chlorine with water is going to produce HCl plus HClO. It gets used as a disinfectant. The reaction might be this one. It's used to kill bacteria. It forms two acids, chloric 1 and hydrochloric acid. As the next one, you got this reaction going on, and the two experiments are carried out in which the amount of R is measured. The results are shown in the diagram. So, which changes in the conditions could explain the results shown? So, a lower pressure was used in experiment 2. Is that true?
No, because the number of moles are same on the right and left.
They're not the same. This side has less gas.
Oh, gas.
You can remember you have to count the gas moles. This side has more gas moles. And the first question, where would the equilibrium shift if you use a lower pressure?
To the left.
To left.
It's going to shift to the left, right? So this experiment does that fit with this description of experiment 2?
Yes.
What will happen to the amount of It does, right?
It'll be less. Yeah.
But the problem with experiment 2 is that it hasn't yet reached equilibrium because the amount of R is still forming. We don't know if it's going to be more or less. Do you get my idea? That the
Yes,
amount
sir.
of R, that the amount of R based on what we just stated was it should be less, right? That the amount of R
Yeah.
should be less because the equilibrium is going to shift to the left. But the problem with experiment 2 is it's not over yet. It's R is still forming. So we don't know how much R would actually be formed. So we can't really comment on that. But by looking at the graph, you would notice that it's a slower reaction. It's taking a longer time. It's a slower reaction. So when you have a lower pressure, the rate would be less. Is that clear? So option one
Yeah.
is, so option 1 is correct. We can't really comment on equilibrium because the equilibrium hasn't been reached at the moment. ठीक है, is that part clear?
Yes.
हाँ जी.
सर ये जो इक्विलिब्रियम है इसके अंदर दोनों साइड्स पर मोल इक्वल है तो प्रेशर से तो कोई इफेक्ट नहीं होगा.
नहीं होगा ना क्योंकि the gas moles, you have to count the moles of gas. You got 1 mole of gas over here. You got 2 moles of gas on that side. As the next one. So the point about experiment 2 is, since it hasn't reached equilibrium, since we don't know how much R would actually be formed because it's still forming, right? It's there's still some time left, and we don't know what amount of R. So we can't really comment on equilibrium. We can't really tell whether there's going to be more R forming or there's going to be less R forming. So the question is, we can't guess any information about equilibrium. What we can guess about is the rate of the reaction. The rate is definitely slow. So are they using a different catalyst? They're obviously using a different catalyst because the reaction is slower. And the last one is product S was continuously removed from the reaction vessel in experiment 2. So the thing is that if you remove S from the reaction vessel,
It will shift forward, right?
it should shift forward, but it's a liquid. Remember, liquids don't really have concentration. This only matters for concentration. Like if you remove a substance and its concentration decreases,
wrong होगा.
it's not going to affect the equilibrium as such. You get my point? That the third, remember the three things that affect the equilibrium. One is pressure, right? But pressure only applies to gases. The other one is temperature. And the third one is concentration. And the term concentration only applies to either gases or to solutions. It doesn't really apply to solids or liquids. So even if you remove this sulfur over here, let's assume it's solid. If you remove it, nothing should happen to the equilibrium mixture. Is that clear?
Yes, sir. So, sir, if it instead it said its concentration was reduced, then it would shift forward.
Yes.
Okay, cool.
So, I mean, normally we use them interchangeably, but remember the term is specifically for concentration. Like if you remove gas R, right, from the mixture, right? Let's say you have a container. So this is gas R. If I remove 2 particles, then obviously its concentration decreases, right? Is that clear? But if there is a
So regarding question option 2, या सर उसके अंदर ये इशू है कि उसके अंदर उन्होंने सिर्फ इक्विलिब्रियम को उन्होंने रिएक्शन दिया है और सिर्फ टाइम ग्राफ उन्होंने दिया है, तो उसके अंदर से तो कोई ये इन्फॉर्मेशन तो नहीं मिल रहा कि यहाँ पे इक्विलिब्रियम को रेफर किया जा रहा है रेट को.
in experiment 2?
Yeah, sir, option 2. Yeah.
This is specifically a graph to measure the rate of the reaction, amount of R with respect to time. So what I stated earlier was that you can, from the graph, you can talk about the rate of the reaction, but you can't talk about the equilibrium. Where is the equilibrium shifting? Because the reaction is still not complete. Why do you clear? If something is not at equilibrium, how can I tell whether there's more R forming or less R forming?
Okay, sir. Thank you, sir.
So moving to the previous one, there's liquid X and Y do not react with one another. They have identical boiling points. A particular volume of X is shaken with a similar volume of Y. They form a liquid mixture Z. So first thing, X and Y do not react. And they have identical boiling points. The average intermolecular forces in liquid Z are stronger than the average of the forces in Xn and the forces in Y. So what he's saying is, there's a bunch of X which are attracted to each other. And now this question is slightly tricky. And there's another liquid which is Y and they are attracted to each other. Now what it does is, they do not react with each other. And they have identical boiling points. So that means they have identical intermolecular forces. We don't know what the intermolecular forces are, but the intermolecular forces are identical. Now the question is, when you mix them together, so X and Y, they get mixed together. So let's say they all mix together. And he says that they have stronger average attractive forces. The average intermolecular forces in Z are stronger. So over here you had weaker attractive forces, and now you have stronger when you mix them together. So what can be deduced from this? The mixing of X and Y is exothermic. Can you?
I think it's endothermic.
So how would you figure out? When you want to mix this, you would have to break bonds, right?
Yes.
So you would have to break these weak bonds, right? Like X and X attraction has to be overcome, Y and Y attraction has to be broken, right? And then you're going to...
Dissolving is always endo, right?
Which one? Dissolving?
Dissolving, yes.
No, it's not endo, it could be exo as well. It is exo in this case. So let me explain. Whenever you have a reaction, some old bonds are broken, new bonds are formed. In this case, what is broken? The attractive forces between X and the attractive forces between Y. Is that clear? I mean, is this part clear? That, and once you break those attractive forces, then X and Y will start attracting each other. So stronger attractive forces are going to be formed. So that is formation. So what is enthalpy change? Enthalpy change is endothermic when you're breaking bonds, right? Energy is needed. Exothermic negative sign when you're forming bonds, right? So bonds broken minus bonds formed. So this value has a lesser value. So let's call that, let's say it requires, because it's weaker forces, let's call it 10 kilojoules. I'll just give it a hypothetical value. So a small amount of energy was needed to break these forces. And stronger attractive forces were formed, so a lot more energy was given off, right? It's exothermic. So only 10 kilojoules of energy were needed to break the attractive forces, but 100 kilojoules of energy were released when you were forming stronger attractive forces, right? So what will this turn into? This will turn into, overall, it's going to turn into an exothermic value. The overall process would be exothermic. Is that clear?
Yes, sir.
Okay. Or there are many ways of thinking about it. Remember, bond formation is exothermic. So if you're forming stronger bonds, then obviously it's going to be more exothermic. Bond breaking is endothermic. So if you're breaking weaker bonds, then it's going to be less endothermic. They're not reacting, they're dissolving. So, I mean, what I'm referring to as bonds, we're not breaking bonds, we're breaking intermolecular forces. The weak attractive forces between them, that's what we are breaking. So we're not forming a new thing, there's just attractive forces, stronger attractive forces. Is that clear?
Yes, sir.
Okay, so vapor pressure is no longer, will be less than that of either liquid X or Z. That is also true. Vapor pressure is no longer in your course. But when you have X and Y mixed together, they've already stated that the attractive forces are stronger. If the attractive forces are stronger, less boiling less vapor would be formed. It's not going to form vapor easily. Is that clear? If you have stronger attractive forces. So less vapor would be formed. If you have less vapor, the pressure exerted by that vapor would also be less. So it will be less. So the vapor pressure of liquid Z, which is this one, will be less than either one of them. And the boiling point of liquid Z will be higher. It's going to be higher, stronger attractive force.
Wrong.
Yeah, that one is wrong. So anyways, vapor pressure is not in your course. Vapor pressure is just simply the vapor, the pressure that is exerted by the vapor when a liquid is evaporating. But is the first part clear? Exothermic. Is this clear?
Yes, sir.
Yes, sir.
Yes.
So the next one, you've got 32. The first, one second. As this one, first ionization energy of chlorine is greater than that of sulfur. Which factors contribute to this? What happens across the period?
Ionization energy.
Ionization energy increases.
Increases, right? Dip at 3, 4, 5, 6. There's a dip, 7 and 8. So I guess he's talking about sulfur and chlorine. So why does it increase? Chlorine has what? Why does it increase across the period?
It has more greater
More
nuclear.
protons.
More protons, greater shielding.
Okay, so it's got more protons.
And net positive charge is greater.
There is no net positive charge. You're talking about the first ionization energy. So right now it's neutral atoms. Chlorine has greater electron shielding. Is that true?
Constant
Yeah.
shielding.
No, sir.
Yeah. Across the
Constant
period,
shielding.
you have the same shielding. So that is wrong. The last one is the covalent bond. Ionization energy has nothing to do with covalent bonds. Germanium has a nuclear number of 70. You can do this on your own. We'll skip this one. First thing, does this have serial bond O in it?
No, sir.
Alcohol.
No, remember, go for this, the first thing. So no C double bond O, 1600, 1700, you got a strong absorption. Anyways, now somewhere around 3400, you're getting so it doesn't have a C double bond O. Carboxylic acid is gone, ester is gone, propanol, so you're left with D because they all have C double bond O's. Esters have C double bond O, aldehydes have C double bond O, carboxylic acid also has C double bond O. Is this clear? Question?
Yes, sir.
Yes.
You can. So always go for try and figure out whether something has strong absorption at 1600, 1700. As next one, you got this molecule and it's formed with
Sir?
concentrated. Yes.
सर वो जो आप स्पेक्ट्रोस्कोपी वाला दिखा सकते हैं?
हाँ.
सर रिगार्डिंग दिस इसके अंदर ये जो फिंगरप्रिंट रीजन जो है इसको हम लोग रेफर नहीं करते ना नॉर्मली.
Either किसी को भी refer ना करो. I mean, I think the most important ones are just go for serial bond O. Yeah, that's the first one. And after that, go for OH. So you can try and figure out these are present or not and what type of OH is present. Most of the questions would be solved using this. Is that clear?
Yes, sir.
So you don't really have to like if I open the data booklet, remember in infrared spectroscopy. You don't have to look at all the bonds. Just focus on serial bond or focus on OH. If there is a question, then go for the other ones, but otherwise it's not important. And most of the time it's not important. Anyways, coming back to the question, are we done with this one? What was the absorption at the 3400 mark? That's the normal alcohol absorption, right? At 3200, 3600, you've got alcohols. The hydrogen bonded alcohols are the ones that are in water, and the free alcohol is the one that's in gaseous state. So next one is, I've got this molecule and it's reacted with sulfuric acid, a cyclic compound is formed. What is the skeletal formula of this cyclic compound? So I've got a CH2 with an OH, and then there is a CH. Then you got a double bond in the middle, and then there's another CH, and then there's a carboxylic acid. So tell me what will happen. What's the kind of cyclic compound would be formed in this reaction?
OH and OH.
An ester.
Ester.
Ester, right? Because you got an alcohol and you got a carboxylic acid on this side. So what will happen is that the C double bond O, H and H, the molecule will bend, and this one had OH, and this side had carboxylic acid, right? So the H and the OH will be lost. So that's gone, and they will connect together. So which one is the correct one out of the four? It should have. I mean, this is gone. This is gone. This is gone. It's got just one C double bond also.
Yeah, so C.
C, does it look like C? Just a second. Like this is the C double bond, that's one. The other second one, you've got a double bond, right? And the third one also has a double bond. Then the fourth one is CH2, and the fifth one is O. Okay, everything matches, checks out. So C is correct. As I got tartaric acid, it's found in many. A sample of tartaric acid reacts with LiLH4 to form the compound J. LiAlH4. So remember LiLH4, it will reduce both things. It will reduce a carboxylic acid to an alcohol, primary alcohol, aldehyde, ketones, everything gets reduced with this.
Sir,
Yes.
if I wanted to reduce carboxylic acid, yeah, is that possible or not?
Which one?
Carboxylic acid to aldehyde.
Ah.
So, like, how do I stop it at that point?
You're saying, okay, should it form an aldehyde or should it form an alcohol? That's what your question is.
Yeah, yeah.
I mean, stop at aldehydes, you would have to distill at some point.
So even
normal-
in reduction.
Because you would have to take out the aldehyde from the mixture.
Correct.
सर
Yes.
सर यही रिडक्शन हम लोग NaBH4 के साथ कर सकते थे.
But the carboxylic acid only gets reduced by LiLH4. The others will get reduced by both things. See? So coming back to this, this is the tartaric acid, and it forms J. So what else? What is going to be reduced? I think the carboxylic acid at both ends, right? So the middle part is CHOH. Then you have the middle part CHOH, another one. And you got a carboxylic acid over here, so that will turn into primary alcohol. The other side was a carboxylic acid, but that will turn into primary alcohol. Right? So this is your compound J. What happens when NaOH is added to separate samples of, will NaOH react with this? Does NaOH react with alcohols?
Yes.
It doesn't. Remember this, that alcohols only react with Na, not with NaOH.
Right.
Who reacts with NaOH? Carboxylic acids react with NaOH. So J is not going to react. No reaction with NaOH. So J is not going to react, but tartaric acid will react. It's got carboxylic acids. So that will only tartaric acid reacts. Is this clear?
Yes.
So then I have compound Q shows the following reactions. Gives an orange precipitate. Who gives an orange precipitate with 2,4-D in pH?
Aldehyde ketone.
Ketone.
Yes, so
Carbonine.
carbonine. So it's got some sort of serial bond. It gives a red precipitate with filling. So is it an aldehyde?
Aldehyde.
Yes, that means it's an aldehyde. It's got H on one side. And it also gives a yellow precipitate with alkaline aqueous iodine. So that means
Methyl group.
CHOH.
it's a serial bond O that has a methyl next to it. Plus, it should be an aldehyde as well. So it's going to be a methyl with serial bond O, but it's going to be an aldehyde as well. So that's the only option. Is that clear? And that's A.
Yep.
Okay, so remember, iodoform test is this one, a methyl with serial bond O. But since it is supposed to be an aldehyde, there must be an H on this side. So this R over here, the rest of the molecule, that's going to be H. अच्छा वापस आ जाओ इसमें this. I got this molecule and it's reacted with NaBH4 now. So NaBH4 again, it's aldehyde and ketones. Both are going to get reduced by NaBH4. So this gets reduced to an alcohol. This gets reduced to an alcohol as well. So you're going to get two alcohols, which is going to give you A, right? Okay, nothing should happen to the double bond. So it's just going to be A. Is this clear?
Yes, sir. Yep.
The other one is compound Y is 55, 36, 9.1. MR of Y is 88. What would be the structure of the alcohol? So remember, it's an alcohol to begin with. So I'm pretty sure you can do this, right?
So we do the empirical formula.
So all you have to do is divide by 12. Divide by 12, divide by 16, divide by 1. Can you quickly give me the values? This is going to be 9.1. What is this?
4.5 for the carbon.
How much?
4.5.
12.5. You can't be 12.
4, sir. 4.
0.27.
Kitna?
For the carbon, sir. For the carbon, it's 4.5.
For the carbon, it's 4.5. And for this one, it's
2.27.
it's 2.27. So I guess divide by the smallest, this will come out to be 1, and this will come out to be 2, and this will come out to be 4, right? Is this what you're getting?
Yes, sir.
This is C2O1 and H4, right? Now the next question is this 88? They've told us that it's supposed to be 88. So is this 88? One oxygen, that's I guess
No,
this is
It's
44.
Multiply by 2.
Okay, so everything gets multiplied by 2. So it's C4, O2, and H8, right? And you can go and have a look and figure out which one it is. The one with 4 carbon atoms. I guess it's this one. But you got two options, right? It's
A or C.
C.
so why C? I mean, there's one issue. So what is X? So it's got
C
4.
has more H's.
It has the same H's. That's 1, 2, 3.
C has 10 H.
This one also has 10 H's. 3, 5, 6, 7, and 3, 10. Right. So
I'm supposed to have an H.
so the question is, now here's a question. So how do you figure out which one it is? It could be, it's an alcohol, right? But it could be any one of them, right? So which one is it? Remember, this is Y.
Oh,
This is not X.
So it's a C acid. It's a carboxylic acid. Why is carboxylic acid?
How do you figure out this is carboxylic acid? That's
Because of the 2 O's.
Yep, you got 2 O's, right?
Yeah. And then what is that? Second degree alcohol mixed up? No, first degree.
Or primary alcohol.
Yeah.
So Y, he said Y is formed from X, right? When it gets oxidized. So a primary alcohol turns into a carboxylic acid. So this is going to be C. Because we found the empirical formula for the product. So it's this particular alcohol, the primary alcohol, that will form this carboxylic acid. Is this part clear?
Yes, sir.
So the next part is you got bromethane, chlorethane are separately added to water. Hydrolysis occurs. So which one will react more quickly? Which one has a weaker bond?
Chlorine.
Bromine.
The bromine.
Oh, sorry, bromine.
Bromine.
Bromine has a weaker bond. Bromine would compound that hydrolyzes more rapidly. Remember, reactivity increases down group 17 for halogen alkanes because the bond easily breaks. And the mechanism is definitely nucleophilic. substitution. Okay, SN1, SN2 reactions. You got this reaction. This is a halogenoalkane. It's reacting, and the mechanism is given. It's a two-step reaction. So which one is it, SN1 or SN2?
SN1.
SN1.
The SN1. In SN1, when you have a tertiary halogenoalkane, Y is going to be a carbocation. It's going to form a carbocation first when you have SN1 mechanisms. Where's the SN1? This one. This primary is a one-step mechanism. Everything happens in one go. Tertiary SN1, that's where you have a two-step reaction. A carbocation is formed. So this thing over here, this Y over here in the middle, that's a carbocation. Okay? Is this clear?
Yes, sir.
While this is for SN2, so this is not. Yep, this is Y. This is the intermediate. So I got this reaction. There's an alkene and it reacts with hot concentrated chemophore. So the question is strong oxidation, right? What is the structure of the alkene? So what's the structure of the alkene? When you oxidize this, when you get this thing, what happens when you do strong oxidation? Double bond breaks, right? And two hydrogens, that turns into carbon dioxide, one carbon chain that turns into carboxylic acid, two carbon chains, and they turn into ketones, right? So what will happen in this case? That the double bond in the middle will break. As a double bond is going to break, and you got these two carbon atoms. What will happen to each one of them? What will happen to the left one?
Ketone.
I said, what will this turn into?
A ketone, sir.
Okay, that turns into ketone. And this one has one carbon chain that turns into
Carboxylic acid.
So if it's turning into carboxylic, is this the correct one now? Are
I
these
think
two
so.
Are these two the same or not? We would have to check. You got one
They're
carbon
not.
atom.
They're
First
not.
thing, this same thing, right? Second one, it's got a double bond. This thing matches, right? Third one does not match, right? Is that clear? Because over here
Yeah.
you don't have a branch, over there you got a branch. So this is not the one. Okay, what about the next one? The next one is kind of the same. It's so your double bond will break, and what will happen? You'll have two carbon chains, right? Carbon atoms. This one is carboxylic acid, right?
Yes.
And this one is ketone, right?
Ketone.
Yep.
Is this and this the same? Starting with the first one, let's start over here. The first one is the same. Second one is the ketone, so that's the second one. On the third one, you got a branch. So we do have a branch, right? And then on the fourth one, and fifth and sixth, so you got the fourth, you got the fifth, and you got this. On the sixth one, you should have a carboxylic acid, right? But over here, you don't have a carboxylic acid. So is this clear as well?
Yes.
Okay, this is not the one. So let's move to the next one. Again, the double bond will break, and so one of them is going to be this one is going to be carboxylic acid. This one is going to be ketone, right? So is this the same?
No, sir. The methyl group is wrong.
There is a methyl, like starting with this side 1,
Yeah, but the one that's
this-
poking
There
out.
should be a branch on the third.
3, 4.
So the one that's poking out is at the wrong area.
Exactly, the other third one, right? So I guess it's this one then.
Yes, sir. It's D.
Padari, we would still have to check. Double bond goes, right? And we've got ketone and we've got carboxylic acid. So 1, 2 is the same, third one branch, fourth, fifth, and sixth one carboxylic acid. This one exactly matches. Okay, is that fine? So D
Yes,
is
sir.
so what type of reaction are alkanes most likely to undergo? Alkanes.
Electrophilic
Electrophilic.
substitution.
C, free radical.
Free radical substitution. Okay,
Oh,
alkanes,
alkanes.
alkanes only have one
Alkanes,
reaction, which is UV light and chlorine. I said, moving, which reaction will, what substance reacts with trichloroethene to give a chiral product? Trichloroethene. Trichloroethene is 2 carbon atoms.
NaCN.
First thing, trichloro. So that's, now it's an alkene, right? So there's going to be an addition reaction. Alkenes don't have any reactions with NaCN or with NaOH. Actually, who has a reaction with NaCN?
Halogen alkanes.
So the Cls will get replaced by CN, right? But that will still not make, I mean, you have to get rid of the double bond. The NOH will also get rid of the Cls, but you'll have OH instead. But you can't have chiral until and unless you get rid of the double bond. Is that clear?
Yes, sir. So BR2.
Yes, sir.
So let's say BR2. If I add BR2, will it be chiral?
So NaCN क्यों react नहीं कर
Yes.
सकता?
The NaCN will react. So this is chiral, right? So an HCl will not make it chiral. HCl can also get added, but HCl, if you put HCl, it's not chiral. Even if you try the other way around, it's still not chiral. So BR2 is the only one that's going to make it chiral. As anyways, I'm just going to repeat why did I cut off NaCN and NaOH, because they were not reacting with the double bond. Like NaCN is a reaction with halogenoalkanes. So the halogen part might get replaced by CN, but the double bond is still there. So you can't get a chiral product if the double bond is still there. Is that clear?
Yes, sir.
Yes, sir.
As a catalytic converters are fitted in the exhaust systems of many cars which gas causes acid rain and is removed from car fumes by a catalytic converter. Iska kya hai?
Nitrogen dioxide.
Nitrogen dioxide.
So now try and understand the pattern, the paper pattern as well over here, that doing the last 20 questions usually takes a longer time. Doing the first 20 questions usually takes a lot lesser time. So try and go through make sure you divide your time accordingly. Okay? When you're doing a paper, a lot of people, they pace themselves incorrectly. They think that the first 20 questions will take 30 minutes. And the next, like now it's 1 hour 15. So let's assume that the first 20 questions, they'll assume that the first 20 questions will take half the time. The first 20 questions should be done very quickly. They should at least take 20, they should take lesser time. The next 20 organic questions usually take a longer time. As anyways, so make sure, don't pace yourself assuming that all the questions take the same time. These inorganic questions usually are much quicker. So which type of reaction occurs when ammonium sulfate reacts with an excess of sodium hydroxide? This is another question. We've done a lot of these questions. What happens in this? What type of reaction is this?
Salt, NH3, and water.
So what is the reaction it's in? Ammonium sulfate reacting with NaOH.
Acid base.
It's an acid base. This reacts as an acid. NH4 gives an H+1 to OH ions. So it donates an H+1. The OH ions, they turn into water. The NH4 loses an H plus 1, turns back into NH3 gas. And what is left is the salt, which is Na2SO4. That's the leftover salt. So it's an acid-base reaction, first one. You got sodium acid is dissolved in water, silver nitrate is added to the solution, and a white precipitate forms. Aqueous ammonia is then added to the white precipitate. So acid ions have similar properties to Cl ions. So when they say that, so they're basically talking about Cl ions. So formula of the white precipitate. What is the formula of the white precipitate? If it had been Cl ions, what was the formula of the white precipitate? The white precipitate is AgCl, right?
HCl.
But now just replace the Cl with N3 minus 1. So it's going to be AgN3, right? Is that clear? So the next is, will the precipitate dissolve when ammonia is added?
Yes, sir.
Yes.
Yes, it's going to be A. Chlorine and bromine have different volatilities. Which one is more volatile, by the way?
Chlorine.
Chlorine?
Yes.
Okay, so it's going to be chlorine. It evaporates easily. Why does it evaporate easily? Instantaneous dipole induced dipole forces are greater in bromine than they are in chlorine. Is this true or is this true?
I guess C.
So, C.
See, because chlorine obviously has lesser van der Waals forces. That's the next one is we've got solution P and Q each contain a different group 2 ion at the same concentration. One contains so Mg2 plus and Ba2 plus. So the solution contains 2 ions. And test 1, you add Na2SO4. So this is your solution. What will happen if you add Na2SO4?
Barium sulfate is insoluble.
Okay, so you'll get a precipitate of barium sulfate in this case. And if you add NaOH, will you form a precipitate with if the
Yes.
ions?
Because magnesium hydroxide is partially insoluble.
The magnesium hydroxide is insoluble basically. So magnesium hydroxide is insoluble. So in this case, you'll get a precipitate of MgOH2, which is solid. In the other case, you'll get a precipitate of barium sulfate, which is a solid. So results in test 1, more precipitate with barium ions. If you do test number 1, that is true.
No. Yes.
Okay, you're getting BSO4. You're not getting MgSO4 because MgSO4 is soluble, right? So it's going to be B. Because who's making the precipitate in the first one? It's barium, right? It's not Mg. MgSO4 is soluble. Okay, is this clear?
Yes.
And in the other one, it's the precipitate is being formed by magnesium. Because barium hydroxide is soluble. So it's going to be B. So the next one is 5 gram. So you have to identify now this question over here. It's a group 2 metal nitrate. Group 2 has a charge of +2. So the formula of the nitrate is going to be XNO3 twice. It's going to decompose to form a metal oxide plus 2 NO2 gas molecules plus half O2. So he's saying that there's a 5 gram sample. This one is 5 gram. And it loses 3.29 grams in mass. So that means the gases are lost. So 3.29 grams of gas is lost. So how much mass is left? That's 1.71 grams, right? Is this clear?
Yes.
So 3.29 grams of gases are gone. And you're only left with 1.71. How do I figure out what X is based on this information? Huh?
Okay. Yes, if you want.
Now there are 2 ways of doing this. One is the lengthier way, which is I'll try one by one each one of them. And I'll figure out that if I have 5 grams of magnesium nitrate, will I get 1.71 grams or not? Acha, but the 2 moles are equal, right? If you have 1 mole of this, it's going to produce 1 mole of this, right? So I'm going to take the moles in terms of X. What is the moles? That's 5 grams divided by the MR. I don't know what X is. I know NO3 twice has an MR of 124. And I know the moles of this as well. Mass divided by MR, which is 1.71, divided by, I don't know what X is, but oxygen is 16. Is this clear? I've taken the moles in terms of X. Is this clear?
Yeah.
Yes.
And both moles should be equal because 1 molecule will produce 1 molecule of this. So I'm going to make them equal. So moles of the first one should be equal to the moles of the second one. And then you're going to try and solve this. It's going to be 1.71 divided by X plus 16. Is that clear?
Yes.
So try solving for X and try and figure out what X is. Did anyone try?
$40.1.
Yeah, that's calcium, right? So 40.1 is calcium. The other way was that you would try with the first one, take this as magnesium nitrate and figure out that if you have 5 grams of this, how many moles would that be? Then you'll find the moles of this magnesium oxide and you'll try and figure out the mass. If the mass comes out to be 1.71, then it's the right one. But then you'll have to do this 4 times. So, but is the question clear?
Yes.
So X and Y and
So
G
could you
are
explain it again, please? I don't get it.
the whole question.
Yeah.
See,
Just briefly.
question is about group 2 metal nitrates, right? So every group
Yes,
2 metal nitrate has the same decomposition equation. Like magnesium nitrate, magnesium oxide, NO2, NO2,
Yes,
right? So I've taken that as X because I don't know what the metal is. The equation is balanced in exactly the same way. So what I figured out was that if the moles of the nitrate and the moles of the oxide are going to be the same every time. Is that clear?
Yes, sir.
So I figured out the moles of this thing. It's 5 grams, right? So how do you find moles? Moles is mass divided by MR. So it's going to be 5 divided by X plus 124, right? Because I don't
Why
know
X
what
plus 124?
NO3 twice is 124. I don't know what X is.
Oh, okay.
And the MR over here is going to be X plus 16. 1.71 divided by X plus 16. Is that clear?
Yes, sir.
Yeah.
And these moles, both of them will have the same ratio. So these moles would be the same as these moles. So I'm going to equate them and I'm going to try and find what X is. So yeah.
So
Haji.
Right.
तो बाकी
So
scenarios
basically
के अंदर कैसे
multiply
कर
both
सकते हैं?
sides by X plus 16 and X plus 124. And then just make an equation and do it.
Yeah.
Basic math, buddy. Basic math.
So
Sir?
Haji.
So ये बाकी scenarios के अंदर भी ऐसा कर सकते हैं जहाँ पे like elements given now.
Sometimes you can, but remember over here, the only reason we were able to do that was because the equation every time is the same. It's the same exact ratio every time. And you can do this in other equations as well. Like if they're saying that there's X plus Cl2 and it forms XCl2, right? And they tell you that there's a 5 gram sample of X and it reacts with Cl2 to form 5.8 grams of XCl2. I mean, just a hypothetical one. So The moles of this, according to the equation, the moles of this are exactly the same. So you can equate them and divide by the MR, which is X, divide by the MR over here, which is X plus 71. And you can do that over here as well. Okay, is this clear?
Yes, sir.
Yes, sir.
Which oxide will increase the pH when added to water? Which one is basic?
SO2.
SO2 is acidic. SiO2 and Al2O3 will not dissolve. Okay, this one is acidic. Metal oxide is basic, but it's only going to dissolve very, very slightly. So it's going to be very slightly basic. So yeah. So, but it will increase the pH. Equilibrium mixture, the sulfur dioxide concentration is 0.2 mole per dm cube and the oxygen concentration is 0.1 mole per dm cube. What is the sulfur trioxide concentration? So remember, it's already at equilibrium. SO2 is 0.2 mole per dm cube. O2 is given as 0.1. SO3, we don't know. I'm going to take it as X because I already have the value of Kc. So Kc is 280. How do you figure out Kc? That's a product concentration. That's going to be X squared divided by reactant, which is SO2 squared, 0.2 squared into 0.1. So you didn't have to do anything. It was already at equilibrium. So what is
सर यहाँ पे वो टेबल नहीं बनाना होता कि initial equilibrium reactor produced.
Because it's already at equilibrium. It's an equilibrium mixture. Initial तो है नहीं वो पहली head पे पहुंच गया.
Distinguish कैसे करेंगे फिर इनके बीच में?
In that case, they will tell you that initially you added this much into a container. So in that question, it is not at equilibrium initially. And in that question, then they always tell you that, and then it reaches equilibrium, right? So that question does not start with an equilibrium. This one it is already at equilibrium. Okay, clear?
Yes, sir.
So you don't have to make the table because the data is already given to you. So all you have to do is find X. What is X? And he did even do this one. What's X?
A.
A, sir. A.
This one is
1.05, yes.
So we've got this one. This is it's X plus Y reacting. It's a reversible reaction. X and Y are mixed together, so there's no Z initially. In a closed system, a dynamic equilibrium is gradually established. Which graph could represent the change in the rates of the forward and reverse reactions over time? So,
C.
Is it C?
Maybe. Maybe.
the first thing, will the rate eventually become equal?
Yes.
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 Yes, sir.
I don't know what B is. What is B?
Abstract art.
Sorry. I thought this was one option. There are actually 4 different options. So it's going to be C, right?
Yes.
Because,
Yes,
because eventually the rates would become equal. Rate of forward reaction equals the rate of backward reaction. Again, you got a redox question and you have to balance this. This one is not organic, so I'll just balance it using the electrons gained and lost. What is the oxidation state of Cl over here?
5.
+5.
Okay, this is +5. This one is check color. This is +7. This is what is Cl over here?
+7.
Okay, this one is +7 and this is +4, right? So Mn goes from +7 to +4. That's a gain of how many electrons? 3.
3.
Yes.
And this goes from +5 to +7. That's a gain loss
2.
of 2.
2.
So I'm going to multiply the first one by 2 and this by 3, right? Is this clear?
Yes.
So
Yes, sir.
3 Cls, 3 Cls. And on the other side, I'll have 2 Mns and 2 Mns, right? And then based on that, I'll balance the oxygens. I've got how many oxygens over here? That's 8 plus 9, that's 17. Is it 17? That's 17, right? So over here I have 4, 3, 12. 12 and 4 is 16. So water would be 1, right?
Yes.
And I can balance the hydrogens as well. That's 2. So Y would be 2, right?
Yep.
So what was he was
Yes,
looking for
sir.
W, X, and Y. W, X, and Y. So it's 3, 2, 2, right?
D.
D. D. Achha, but remember again, I'm going to tell you that you can't do this one exactly for organic molecules, especially the ones that are more complicated, because it's harder to figure out the oxidation states of carbon over here, because every carbon would be different. Some would be bonded to oxygen, some would be bonded to hydrogens. As a sodium burns in oxygen, giving out heat energy, and the equation is shown, and the statement about the reaction is correct. The enthalpy for the reaction is equal to twice the bond energy of the NaO bond. This is correct. How many bonds
No.
are you breaking and how many bonds are you forming in this reaction? Yeah, in this reaction, you're also breaking the oxygen-oxygen bond as well, right?
Yep.
Yes, sir.
So the enthalpy does not only depend on the NaO bond, it also depends on the bonds that you're breaking, which are oxygen-oxygen bonds. So the first one is wrong. The enthalpy for the reaction is positive. Sodium burns in oxygen, giving out heat energy.
No, sir.
No, sir.
Exothermic.
It's
Negative.
endothermic.
Okay, so the equation represents the standard enthalpy change of combustion of sodium. Does it?
Yes. No, sir. It has to be 1 mole.
No.
It has to be 1 mole of
No,
sodium. The last one is correct. That it is the enthalpy change of formation of sodium oxide, because it's 1 mole of forming from its elements. And the elements must be in the standard state. I got this one. What formula would you use if you know the enthalpy of formation of the reactants as well as the
Product minus reactants.
Okay, so this would be product minus reactants. N2 would be 0. So product, what's the product? That's enthalpy of formation of the products. N2 is 0. The other one is 4H2O. That's 4 times minus 241. Be very careful with the signs. So that's my product minus my reactant. That's 2N2H4. So 2 times 50.6 and 1N2O4. That's 9.2. What do I get?
B.
Okay, so you're getting B for this. So remember this. It doesn't matter what the reaction is. Remember, this is the #1 confusion. We don't care what the reaction is.
No, sir. Not B.
It's not B. What is
It's
it?
A. It's A, sir.
A.
Okay. So I'll just repeat. I repeat the #1 confusion. Don't focus on this equation. The equation could be anything. Okay? It could be any equation: combustion, neutralization, any equation whatsoever. It doesn't really matter. What matters is what data is given to you. If you're given enthalpy of formation of everything, you do enthalpy of formation of products minus the reactants. If you're given the enthalpy of combustion of everything, then you do the enthalpy of combustion of the reactants minus the enthalpy of combustion of the products.
Sir,
अच्छा, हाँ.
sir, in general, वो bond dissociation का क्या होगा?
Well, the bond broken minus bonds formed. Like if you're going to break the bonds and you're going to form these bonds. So bond broken is usually the reactant bonds that are broken, and bonds formed are the product bonds that are formed. Okay, so in a way, it's reactant minus products, like bonds broken of the reactants and the bonds formed in the products.
Okay, sir.
So we can do this one. We'll skip this one. Ethanol and this thing are 3 organic compounds. Which compound has the highest boiling point, and what is the interaction? So which one out of the 3 has the highest boiling point? This is easy.
Ethanol.
I think ethanol.
Okay, and why?
Hydrogen
bonds.
bond.
Hydrogen bonds.
Hydrogen.
So you've got this one. How many of these compounds have an odd number of sigma bonds? Odd number of sigma bonds.
Two, sir.
I mean, you would have to draw all of them in this case. C2H4 is this thing. How many sigma bonds?
5.
5.
Yeah, that's right. C2H5OH. That's
8.
3, 4, 5, 6, 7, and 8. So that's not right. Aldehyde, double bond, and single bond, right? That's 1, 2, 3, 4, 5, 6. That's also the last one, CH3 and C double bond O and H. So that's 3, 4, 5, 6, 7. So that's 2. Which molecule contains the smallest bond angle? Smallest. What's the bond angle in C2H4?
120.
120.
120.
Okay, what are the bond angle C double bond O and you got CH3, right?
That's 120 for the C double bond one.
And the CH3 part will have an angle of
109.5.
109.5. What about NH4 plus 1?
109.5 is it?
104.5 maybe.
Nee, that is tetrahedral. It's because
No,
one of
but
the
it has a lone pair, no? So we
no,
don't
it doesn't
count
have a lone
Okay.
pair.
that? No.
NH3 has a lone.
NH3 has the lone pair.
So what is the bond angle?
107.5.
107.
Okay, the one lone pair, there's more repulsion. So instead of 109.5, it's actually now 107. So it's going to be this one. Now, diamond is a pure form of carbon. The mass of a diamond can be measured in carats. 1 carat is 0.2 grams of carbon. What expression gives the number of carats that contain 6 times 10 power? That's 1 mole of carbon atoms, right? So what is the mass of one mole? That's 12 grams, right?
Yes.
So it's 12 grams. And he's saying which expression gives the number of carats that contain. So how many carats is this?
12
12
divided by 0.2.
Yeah, because 1 carat is 0.2 grams. So if you have 12 grams, that will be 12 divided by 0.2. Okay, so basically, these many atoms have a mass of 12 grams. It's the MR. It's 1 mole. A last one, if the same reaction is carried out in the presence of a catalyst, which statement is correct?
C, sir.
In the presence of a catalyst, everything remains the same, except the Boltzmann distribution. No energy is added to the system. Nothing happens, except for the catalyst reducing the activation energy. So it's C. ठीक है. तो ठीक है. और कोई क्वेश्चन तो नहीं है किसी का?
सर एक जल्दी से क्वेश्चन कर सकते हैं प्लीज?
हाँ.
मैं चैट में भेज देता हूँ पेपर.
पेपर नंबर नहीं है. पेपर नंबर.
हाँ. May June 21 variant 1.
Variant 1-1.
जी. Question number 22 कर देगा please.
Question 22 is this one.
Yeah, sir.
He's saying which compound could show both cis trans and optical isomerism. So that's
Yeah, because I was under the impression that for cis trans you need to have same group on at least on like the carbons. But now these have.
it's not about similarity. It's about each carbon should have different groups.
Achha, so it's not necessary that the left carbon has the same group as the
Yeah.
right one?
So these two need to be different, and these two need to be on the other side. They need to be different.
Is it B?
So it's going to be B.
Yeah.
Achha, but
So-
the question is slightly incorrect because you don't use the cis. I mean, it's the same concept, exactly same concept. This will show cis trans because it meets the requirement. Except you don't use the cis trans terminology for this. You use the EZ terminology because it's the only problem would be you wouldn't be able to identify which one is cis or which one is trans.
Yeah. Okay. So you don't need to have the same group on the left and the right. For
Yeah, I
Cis
mean the two sides they can be different. They could be the same.
So why can't it be C?
okay.
It can't
There's
be
no
C
chiral
because
carbon.
It
There's
doesn't
no-
have a chiral carbon.
no
Alright.
chiral. This one has chiral but no cis trans. Achha, so
Yeah,
so
that's
the
okay.
only problem is you only study cis for cis trans terminology to work. So the naming could work. At least one group must be the same. Do you get my point?
Okay, but then there's no group that's the same in these. So that's
Yeah, so you can't use the cis trans terminology. It's the same thing, but it's you can't identify cis. To identify something as cis, at least one group must be the same on both sides.
all right, sir.
So you use a different terminology which is not in your course, but it's the same thing. It's the same thing. Okay.
Okay, cool. Thanks, sir. Have a nice day.
Okay, take care.
Officer.